Hello everyone, so let's solve Leetcode 167 2 sum 2. So we are given an input array that's already sorted in ascending order, and we want to find two numbers that sum up to some target that we are also given. So in this case, the target is 9. The two numbers that sum up to 9 in this array are 2 and 7, and we want to return the indices of these two values. But the catch here is the indexes are 1 based. They are not 0 based. So the first element has index 1 and second element has index 2. I don't know why exactly they did that in this problem. It's kind of weird, but they did for some reason. We are also guaranteed that there's exactly one solution that we can't use the same number twice. So in this example that they gave us, the two first numbers sum up to the target. So that's not really a good example. So I'm gonna look at my example over here that I drew. So the first idea that might come to your mind is just look at every single combination of two numbers. So let's say we are starting at the first number 1. Let's look at every number combined with 1 and see if it can sum up to the target 9. So first we check 1 plus 3, that's 4. So it's not 9. Then we check 1 plus 4, that's 5. Then we check 1 plus 5, that's 6. 1 plus 7, that's 8. And 1 plus 10. So now we have gotten to the point where at 1 plus 10, the interesting thing about this is the first combination that's greater than target 9. So do we have to keep looking at the next element since we know that array is already sorted? So since 1 plus 10 is already greater than the target, we don't have to look at the remainder of the array because there's no number that could possibly come after 10 added to 1 that would ever be the target. Every number is gonna be greater than the target. So we don't have to consider 11 anymore. So we basically remove it from consideration from our array. So we didn't find the two numbers that sum to the target. So now let's try if there's any combination with 3 that would possibly sum. So we start at 4. So 3 plus 4 is 7, it is 8, and 3 plus 7 is 10. So this is the first combination 3 plus 7, which is 10. That is greater than the target 9. So we don't have to look at any number that comes after 7 because we know that it will never equal the target. So we can basically say 10 is removed from consideration. We don't even have to look at it. So we couldn't find a combination with 3 that could sum to the target 9. So now let's check the next number. For the first number to 4 is 5. In this case, 4 plus 5 is exactly our target 9. So we found the solution. Of course, since we found the solution, we don't have to consider any element that comes after it. So in this case, 7 is removed from consideration and we can return our solution. And remember that these indices are 1 based on 1. So first index is 1 and second index is 2. 3 and 4, so the index that we are going to are 3 and 4. So since this is a brute force solution and we are having to iterate through the entire array, which is length n, and we are going to potentially do that in the worst case n times for each number in the array. So then that means our worst case time complexity is big O of n square. So it's not very efficient, but we can use the fact that this array is sorted to our advantage. Let's look at the picture we just drew first. We eliminated 11 from consideration in the array, then we eliminated 10, then we eliminated 7. So we are basically eliminating elements from the end of the in reverse orders. This is basically the intuition. Remember that this array is sorted. We can use that to our advantage. So let's try the exact same problem with a slightly different algorithm using what we just learned. Our target is still 9. Since we are eliminating elements from the end of the array, we can use two pointers. One pointer is going to be at the beginning, left pointer. One pointer is going to be at the end, or the right pointer. So we currently have 1 and an 11. Let's these together. 1 plus 11 is equals to 12. So that's greater than 9, our target term. So since this target is too big, we need to decrease it. We have a choice of which pointer to shift. If we shift left pointer here to 3, we are going to be increasing the sum. We don't want to do that. Since the sum is already too big, so instead let's take our right pointer and shift it to 7. Now we have decreased the total. So let's recompute it. 1 plus 7, that's 8. That is smaller than 9. We went a little too small. We decreased some too much, so now we need to increase it. So since the array is sorted, we can take our left pointer and shift it to the right to increase our total sum. Now we have increased our sum, so it's now 3 plus 7. That's 10. 10 is greater than 9. So we went too far again. Right now it's too big again. It's bigger than 9. So what we have to do this time, well, we want to decrease our sum. So we are going to take the right pointer and shift it to the left. So now we have decreased our sum. Let's recompute it. 3 plus 5, that's 8. So again we got a little small, but we are guaranteed a solution. So we are gonna keep looking. Since our sum is too small, we are gonna increase it by taking our left pointer and shifting it right. Now we can't really shift our pointers anymore, so we better be at the right solution. Let's check for 4 plus 5. That's 9. That's exactly 9. So we got our target, and so we want to return the indices of these with going to be 3 and 4. Right? In this case, we don't have to iterate through the entire array more than once. And these left and right pointers are never going to cross each other. We don't need extra memory either. So our time complexity in worst case is a big O of n. We found a linear algorithm using two pointers to solve this problem. We didn't even need extra numbers. Now we are ready to code up the solution. So we remember we have two pointers, left and right. The left pointer is going to be at the beginning of the array. So index 0, the right pointer is going to be at the last index length of numbers -1. And we need to loop to iterate through our array. The condition in this case is left is less than right. So we are going to return a solution no matter what. So like we just did in the example, let's compute the current sum, and we remember if our current sum is too big, so if it's greater than the target, we can decrease our sum by taking our right pointer and shifting it to the left. On the other hand, if the current sum is too small, we want to increase our sum by taking the left pointer and shifting it to the right. The last case is that our sum current is exactly equal to the target. In that case, we want to return the indices left and right. But remember, they are based on 1. So we are going to add 1 to each of them. We can put our return out here. But it's not needed because we are guaranteed a solution where a loop will return a solution. It works perfectly. Linear time algorithm with no extra space. Make sure to like this video if you find this helpful and subscribe if you want. Until then, I'll see you in the next video. Bye-bye.